Hello everybody. It's freezing cold here in Milan. I thought it was cold in Denmark, but apparently I brought the cold all the way down here south. I was actually swimming yesterday in Denmark and it wasn't cold, and today it's cold here in Milan, so it's good to be here.
We have done our best to...
Yeah, I feel at home.
Thanks.
So my name is David Zahle. I'm a partner at BIG. BIG is currently two headquarters, one in Copenhagen, where we are around 180 people. Historically, most of our build work has been done in Copenhagen and Denmark. The VM houses is the first example of actually cheap housing that we based a lot of our office on for the first couple of years. Then we did the mountains, and which was basically this stack of 80 penthouse apartments on top of a parking house. And we spent, you could say, the first 6 years since 2001 until 7 constructing quite profane buildings in a Copenhagen context. Here's the 8 house. And then around 6 years later, we started our office in New York. We moved 4 people to New York to work on a specific project where we found that the distance was too long to do it out of Copenhagen. And then it went quite fast, and now we just turned 200 people in New York. And one of the projects that we started in New York is working for Google, which has now asked us to do their headquarters in London. So now we also have 20 people in London. So we just turned 400 here a couple of days ago. And the New York office, with its 200 people, just finished the first building, which is quite insane, that you are actually working on 50 different projects at the same time as your first building is getting realized, which is this testament to that in architecture often is, you could say, a gentleman's sport, an old man's game where you become increasingly better at it the older you get. And a lot of people don't get to build before they turn at least my age. Whereas we have been fortunate to get a head start and start up as a quite young office. But I think it's quite amazing that there's been 5 people working pretty constantly on this project, and now it's finished and we are 200 people, which is has been quite a travel. Personally, I've been working with Bjarke for the last 15 years, and we are now 12 partners in BIG, and basically work in 20 different countries. So the VIA, or the West 57th, as it was used to be called, is basically a courtyard building where all the apartments have this fantastic view over the courtyard and onto the Hudson River. It's in many ways constructed in the same way as we built in Denmark, out of prefabricated concrete elements, not a steel building like the one we're sitting in. It's probably steel and concrete here, but and the second building that is just about to be finished, that we're doing right now, is the complete opposite. It's in Miami. It's also housing, but it's all cast on site because of the cheap labor that comes from Mexico over the borders. And in Florida, almost all concrete gets cast on site, which allows you to work with a completely different structural system. Basically, we are working with these twisted, or at least the tilting columns that gives a quite unique experience into each apartment. These are, you could say, the New York project is basically rental apartments, whereas these are for sale. They're quite big. I think the biggest ones are like 300 square meters, so it's like really large, and the cantilever from the column to the edge. I don't know if I can walk out here, but I probably can't. I'm gonna stay here. is more than 5 meters. So it's a completely different structural setting than the one that we have been growing up with in Denmark. And speaking of like in situ cast concrete, I'm gonna go on to the project that I'm mostly here to talk about, the Maritime Museum. So the Maritime Museum is basically a transformation project transforming a city that used to be and has always been a harbor city, and a harbor city that has gone through, you could say, two main identities. The first identity was the castle Kronborg, famous for being kind of the home of Hamlet by Shakespeare. And in year 2000, it was named a UNESCO World Heritage Site. And on the contrary to Italy, where you sometimes have the feeling that the entire country is UNESCO World Heritage, in Denmark we only have 3 things that are UNESCO World Heritage, and Kronborg is one of them. The first thing that UNESCO said to them was that they had to clean up their business case. And one of the things that UNESCO did not like was the fact that the Maritime Museum was lying on the first floor. It had been lying there for 100 years and was, we thought, quite connected to the history of the city. But UNESCO wanted to list the Kronborg Castle for its virtues back in the 15th century. So they thought that everything that did not have anything to do with the castle's history from the 15th century had to be eliminated. So basically the museum was thrown out of the door, and as a homeless person, it started wandering around the city looking for a new home. The reason why Kronborg Castle was the main castle for the king, even though he did not live in the city, was because of the taxes that all the ships that sailed into the Baltic region had to pay when they passed the most narrow spot in the sea. And you could say that was the golden age for the city of Helsingør. The second golden age was the industry, the industrialization, and this was the harbor, how it used to look at that time. And as you can see, it was completely taken over by industry, by a big wharf that built and repaired ships that sailed all over the world. And the dock that we ended up building in was one of the docks that was constructed in 1952. It was actually a dock that was constructed around an older dock. The older dock was made out of granite, and they basically docked around the old dock while they still used it, and then built a concrete structure around the old stone dock, and then tore it down afterwards, which in many ways resembles what we ended up doing for our proposal for the museum. So a lot of famous Danish ships has been built in this wharf and in this particular dock. But when we came up there, the dock was filled with water. It had actually been filled with water for more than 20 years and had not been emptied. So we had no idea what the state of the concrete and of the dock in itself was. We went for a walk around it and tried to imagine the space that we were supposed to create down there. And you could say that I think the only people that actually knew how the dock looked was the firemen, because they'd thrown in a couple of cars and put in some dolls inside them so they could swim down and practice how to rescue human beings if they were about to drown inside a car. We didn't have a diver's license or equipment with us, so we had to use our imagination. And we started working on the competition, reading the brief. And you could say, often when you work on competitions, what you do is that you read the brief very carefully. And what the brief said was that we were not allowed to build as much as a meter out of the dock. We basically had to put the museum inside the dock, put in some skylights, and the reason for that was because it was within Kronborg's 500 meters radius, which was listed by UNESCO, and nothing could block the view of how the castle looked, because the Swedish people once sailed around the castle and attacked it from the back, and they had to restore all the ancient fortifications to how they looked in the 15th century. And it was important for people nowadays and for tourists and for UNESCO that you could actually see how the fortification worked at that time. But often if you concentrate and after you've read the brief a couple of times, you start also reading not only what the brief writes on each line, you also read what's in between the lines. And in between the lines, we could read that what the museum director actually wanted was a Guggenheim in the hold. They wanted some more attention. They wanted new audiences. They wanted to be a magnet for tourists. And that was not allowed because we could not build as much as a meter out of the ground. And we thought, okay, so this maybe is the challenge of this project. How do you build an invisible icon? After that, the next range of questions that we asked ourselves was, how do we actually preserve the historical dock? One of the things that was very obvious was that the dock was both cold and wet. There was actually water leaking through the walls when you would empty it, because there was just water outside on the other side of the walls, and it was cold. So you had to insulate it in order to use it. And by insulating it, you would take away the texture of the historical dock, leaving it pretty stupid to preserve it in the first place. So we thought, okay, maybe what we should do was actually to insulate it on the outside. And we discussed it with the engineers and came up with the only plausible solution, which was to hammer down a sheet wall, steel wall around the dock, and then dig it out, pump it dry from water, insulate it on the outside, put in earth anchors to hold the wall back, and then put it in the dirt, and then we could kind of change the surface of the walls on the inside. And we thought maybe that was quite a lot of effort to go through just in order to change the texture of a basement wall, which it basically was. But then we got the idea of saying, if we anyway have to dig all the way around the museum, why not put the functions out there, liberating the dock from functionality and program, and actually turning the dock into the icon, the hidden underground icon, and in a way preserving the history of the Maritime Museum, the dock itself. So that's how we arrived at the project, that basically you could say took the question that we had asked, that was asked us by the competition organizers, and turned it inside out and just added in 3 bridges. The first bridge in the middle is called the Kronborg Bridge. It's the main access for all the people going to Kronborg, which is one of the main tourist attractions in Denmark. It has close to 1 million people coming every year. And this was also, you could say, a highway bridge because cars had to pass on it. So it was a quite heavy bridge. And it was defined to be 13 meters wide and exactly placed where it's placed in the local plan, and that couldn't be changed. The next bridge is the harbor bridge. The harbor bridge is the one that kind of holds the water out of the museum, and at the same time it provides a harbor promenade that is 8 meters wide and a possibility for a fire truck to go out on the bridge that you see there, which defines the width in the other side. So that was also completely defined by the local plan. The only bridge that we actually added was the main entrance, which we call the zigzag bridge. That had to be 1 to 25 in order to fulfill the Danish regulations for disabled and handicapped people. And there was no room in the dock. It was simply too long. It had to be 80 meters long. So in order to get it down into the dock, we basically had to bend it on the middle and push it down into the dock, which then performs as the main entrance and leads you into the museum. Underneath all these 3 urban bridges, we then put in the functions that either should be visible from the city by being, for instance, the changing exhibitions, so that they actually become like a vitrine for the exhibitions that change runningly, or the cafe which needs more daylight and more access to the dock. When you enter the museum, the rest of the floor is also a tilting surface. It leads you all the way around the dock and down to the level of the bottom, but it's 300 meters long, so it's so shallow that you hardly feel it. It's more like walking on a plain surface that just tilts enough for you to barely recognize it. It more feels like that the space just slowly expands. And you could say, in order not to create 2 long corridors on each side of the museum, we shifted the orientation of the outer white box around the museum, so that the dock is 90 degrees to the shoreline that was in the industrialization in the 19th century, and our building is 90 degrees to the historical waterfront that was there in the 15th century and the one that's there now. So it's basically, you could say, the inherited discrepancies and the development of the harbor area from the different epochs that defines the geometry of the museum and turns it into these kind of expanding spaces. And underneath the first part of the ramp, we then added in the administration offices for the museum. And what you see to the right is a 150 meter long space that becomes more and more narrow. And back in the 15th century, when architects and painters discovered the art of drawing a perspective, they also started working with not having parallel walls or parallel columns in order to emphasize the feeling of grandeur for the emperor. When you walked up through the hallway towards him, he would look bigger. And that's exactly what happens here. So the space that you see to the right almost looks infinitely long, but when you look at it from the other end, it looks less than half as long because the walls are expanding. So this kind of helps break up the monotony of walking around the dock, because the space is constantly expanding and contracting as you walk around. When you get to the end, when you are on the level of the bottom of the dock, a big grandiose staircase warps up and leads you back up onto the entry. It basically, the bottom step follows the bottom floor, and the top step follows the top floor. The top one even tilts in order to meet the ramp, so it actually tilts 1 to 25 to the side, whereas the bottom one is straight, which was quite hard to draw back in the days where you only draw 2D drawings. And we did this project here in basically in most of it in 2D. The steps are made out of concrete as the rest of the floor, and the sides of them out of aluminum as the bridges are. On the way you pass through the cafe, where this is an image of one of the toilets there, where basically the angles of the museum turns the mirror in the toilet into this almost infinite loop. This is the cafe, which hosts the other big staircase in the project. This staircase is much more functional because this is actually the fire escape from all the people. If there's a fire, everybody runs out into the dock and then has to run up the staircase. So this staircase needed landings. The problem was the dock was not wide enough to contain a staircase with landings. So we found out that if we took one of the sides and made straight steps, then on the other side, because it was on the diagonal, that side actually became longer, and there was room for landings on that side. So basically, the two sides of the staircase have either the fast route up from one side or the more slow for people that needs a break on the way. There's light integrated into the railings to emphasize the difference between the two sides, but also, of course, also to provide light onto the staircase if there's a need for fire escape. One of the main details of the project is, of course, the cut between the glass and the concrete. The concrete walls are more than 1.5 meters thick, and cutting through them is quite difficult. You have to cut with either diamond wires or with big diamond cutters. And the precision of something like that is not as great as you would hope for. The funny thing is that normally, you could say for us, of course, the precision between the glass and the concrete was the most important part of the entire architectural project. At the same time, the people that normally tear down things in the building industry are the kind of the lowest part of the hierarchy. You know, they basically just put on something over their ears and then they just start like hammering away. And if you tell them that they have to, you know, hit a tolerance of plus minus 5 millimeters, they will look at you, they will probably smoke a joint, and they'll like just go back to work and just like hammer down everything. So in order for us to actually carry it through, we had to spend quite a lot of time on the site and explaining to some workers that normally are left alone and don't get, you could say, the privilege of actually understanding the architecture of the project they're working on, to make it understandable for them that they were actually our most trusted workers on the site. And it was extremely important that they understood that. And when we got to the point where they made some mistakes, but we had explained them how important it was, they actually started taking pride in doing a good job, which I think is it's pretty hard to teach in architecture school, but it's actually an extremely important part of becoming an architect is communication with the people that actually carry out the work that we sit and spend so many hours on designing, and actually get it to the point where it gets carried out in the way that we wanted. So that's just to say that the transition here between the inside space and the outside space was, of course, of utmost importance to us. And the other really important thing for us was to eliminate structure from the facade, because we wanted the view of the dock to be more like an understanding that the bridges were floating through the dock, and you had a completely undisturbed view of the historical setting, instead of having a lot of structure in the facade. And first, when we started working with the engineers, of course, they came back with a structure that looked like this, and that would have completely blocked the view from inside to outside, perspectively, when you walk through the bridges. So we asked them to look at Ferndale trusses instead, but they just got even bigger. So we came up with this idea of actually, instead of creating 3 bridges, to create 6 bridges, an upper bridge and a lower bridge for each of the 3 bridges. The upper bridge has a solid railing which acts as part of the structure, and the entire thing is made as a box girder which you can understand. This is the engineer standing with a box in his hand, and the moment you don't have a lid on it, it's very flexible. But the moment you put on the lid, it's very stable. And that's basically how the entire structure is. So on the top part of it, it's a solid piece of 4 centimeter steel. On the lower parts, it's a solid piece of 2 centimeter steel. And in between, it's quite thin, but a lot of ribs that actually turn it into this box girder. And suddenly, we were able to basically span 35 meters. Normally, you say that for each 10 meter you span, you need 1 meter of height on the beam, like a thumb rule. So this is 35 meters, so it would need to be 3.5 meters. And we ended up getting the lower bridge down to 60 centimeters, even though it had to span 35 meters. The top one has help with the ears, basically, that goes up on the side. We call it the Batman bridge on the upper one. And the upper bridge, that's a little stronger, helps its younger brother below by hanging it on the central points, basically halfen the span, so that the lower bridge only spans 18 meters and 18 meters. This is the finished experience of the building, where you really see both that the structure and the chains that we ended up using are kind of very visible in the architecture, but also that you have this fantastic view of the historical dock, and really get an understanding of how the historical dock was used, because that's basically why we're doing this project. That's what we're celebrating. The chain is a normal anchor chain from a boat, and it's instead of a tension rod, but it has the same, you could say, properties as that. And there's 4 of them hanging in between the bridges, and each, the upper and the lower bridge, is supported on 6 points, whereas only 1 of them is held in place. The rest of them are lying on joints that can move, which means that when people are walking on them and when they are hot during the summer, they actually can move quite a lot. They actually can move up to 10 centimeters, which is quite a lot when you have a bridge that has a glass facade. So there was a lot of tolerances that we had to build into the connection between the old concrete dock, which is extremely stiff, and then these very soft bridges. Inside the box girders, we added all the technical space. As you can see, there's very little insulation on the top and on the bottom. So it's really like a very minimal, especially for Denmark. I mean, you don't use as much insulation down here, but in Denmark, normally on a roof you have around 40 centimeters, but here we used high-grade insulation, so we got it down to about 10-15 centimeters instead. And inside the bridge, it's stuffed with mechanical ventilation and pipes and drainage and electricity. So it really is a multifunctional steel case that performs both structurally and with all the different MEPs. That was constructed on a ship wharf in China, which turned out to be the cheapest way of constructing it, and then lifted onto a ship, sailed over the ocean as part of this whole global process of constructing buildings in our time. Each of the pieces that were kind of ready-made from China was up to 100 tons, and then they came to the Helsingør harbor as the biggest ships that had ever docked to the city, and got lifted off and put in place with less than 2 centimeters of tolerance. So it was a very high-end construction job, and they fitted pretty okay, not as perfectly as we had wished. So we actually ended up doing a 3D scanning of the old dock that also had moved quite a lot after we started working with it, and the steel, in order for us to do the finishes. So we did like a 3D scan of the entire thing before we started cladding it, and had to basically redraw the entire cladding and the entire build-up to fit into the geometry that was needed. The facade, as you can see, is quite transparent, and the meetings between the dock and the concrete and the glass is quite precise. There was, of course, a lot of damage, and this is even like the door you see underneath the bridge is an escape route. But the main thing for us was to keep the edges of the bridges as precise and small as possible. So we really work with getting the glass almost all the way down to the bottom of the steels. Basically, the construction steel stopped half about 750 millimeters from the facade, and from then on it was just like a small steel pin that then holds the glass. On the top it goes up, but because of the dilatation and the movement of the bridges, the glass can move up and down 10 centimeters, which also of course is a big part of the technical solution. The next bridge I'm going to talk about is the Kronborg Bridge. The Kronborg Bridge is what we call it at the top, where it's a concrete bridge, because that's a highway bridge where big cars goes, and then we have the two lower bridges, which we call the Auditorium staircase and the museum ramp. Those two bridges are basically the entire width of the 13 meters in each end, but then they pull back in order to allow the other bridge to go around it, and then interlock, forming an arch. And basically they support each other. So instead of it being one plane that is very soft on the middle, they actually interlock and becomes much more stiff. So it was possible to get the steel down to between 20 centimeters and 40 centimeters in the construction of it. And one of them is then used for the auditorium, and the other is a shortcut from one of the museum sides to the other. Here you see the technical drawings of it, and here you see them in their most purest form, where you can really experience that it is actually, you could say, two different structural systems, but actually almost three different independent bridges that span the dock, which really helps creating a space that is very transparent and where you really feel the length of the dock. The dock is 150 meters long, 20 meters wide, and 8 meters tall, and in that way it's probably the biggest exhibition piece in any museum in the world, because it's actually exhibited within the museum. The auditorium is capable of holding around 150 people, and the bridge for the shortcut is actually used a lot by children to play on, just as a kind of informal playground. This is, let me see if I can start it. This is a typical day on the Maritime Museum, where it's filled with life, and actually you could say the parts of the museum that are not programmed are often the most lively ones, both here on the inside, but also the dock is quite filled with people. There's hardly any wind down there because of the shelter of the walls around it, and it's used by the cafe for outdoor serving. But it's also used, for events, different events during the year, operas, theater shows, where it can be enjoyed both from putting up chairs in the dock itself, but also from the edge of the dock here on a normal day where people are just enjoying the dock itself. But on big events day, people actually gather all the way around the museum in the urban landscape on the ground floor, on the top, and see what happens within the dock. So it actually has become this almost sunken square in the middle of the city, filled with life at different times. The section of the bridge looks like this, and as you can see, the detail at the top is also something where we worked quite a lot to make it as minimal as possible. It's actually quite thick, and it has the same detail at the bottom as the other steel bridges did. And it was important to us, and you can see even the reflection in the glass is part of making the dock look like it's actually continuing through the bridges, really forming this old frame for the life in the dock, and for actually preserving the experience of the historical dock. And I would say, to me personally, the experience of walking underneath the bridges is probably the most powerful architectural experience in the project. The last place where we also wanted to have a very minimal cut between the glass and the concrete was the glass that we put in for the administration below the ramp. And there the detail was very different. It was not a detail in section, but more detail in plan, but with the same principles. But because the wall is 160 deep, and then has insulation on the back side of it, it actually ends up being more than 2 meters deep. And then we wanted the concrete and the glass to meet perfectly on the edge, so it the insulation kind of tapers off when it comes towards the facade. Another important detail for the project is the railing. Basically, the entire surrounding urbanscape around is a square filled with cars and people. And one of the things that we very quickly realized was that we wanted a very transparent railing, but it had to be able to stop cars. So you would very easily end up with like this kind of highway railing filled with a lot of steel, and we wanted the most transparent glass we could find. So instead of we did two things to kind of minimize the impact of the railing. First of all, we kept the height of the railing from the historical dock, so we kept it down. We had to raise the surrounding urban space around in order to protect from flooding. At least in Denmark, the flooding requirements are that they need to be 2.4 meters above normal sea level, whereas historically when the dock was constructed, you only had 1.8 meters. So the 60 centimeters is used as a step, partly a step down, which makes the railing look lower. So that when you are walking around the dock disappears even more. But then, as the other kind of trick to make it disappear, we decided to separate the railing that should stop the cars from the railing that should stop the people. So the railing that stops the cars are these fenders that are kind of like an artificial fender that is benches and chairs that are shaped a little bit like these historical fenders that you connect your ship to. And then we started playing with how we should organize them around the dock until one day we realized that since we now then had a chair and a bench, we could actually use it as a Morse code. So around one of the holes, it says MS Museum for Maritime, and on the other one, it's a quote from H. Christian Andersen, the famous Danish poet, who says, to travel is to live. So when you get there with your kids, you can go down into the reception and get the Morse alphabet and go upstairs, and they can practice part of what it is to be a sailor, which is to be able to write, make yourself understood in Morse code. But of course, the most difficult part of the project, seen from the engineering part of things, was of course that it was filled with water. There's a harbor right out on the other side, and you had to create, you had to dig around it. And we started looking into how we could work with this, and we found out that the first problem was that the dock floor, which is actually 2.5 meters thick, it had to continue 5 meters out on the other side of the walls in order to be heavy enough to hold the dock down. And it was the earth that was sitting on top of it that was holding it down. So the moment that we would start digging around, the dock would pop out of the water and lift 4 meters out of the ground. So we had to anchor it in before we could start digging. The problem was that in order to anchor it in, we had to pump away the water, because otherwise, the moment that you drill through the concrete, you would have like a 8-meter tall fountain of water that you had to kind of drill against, which is impossible. So the first idea was to just do what you normally do, you just pump away the water. The problem is that the harbor is so close that I think it was like around 20% of the entire building budget would be used just for the energy for pumping. So that was hardly a good idea. And the second problem was that it was so close to Kronborg that Kronborg would probably start to get sediment damages, which would definitely not be the best commercial start for a new museum. So then we thought, okay, but we need to drill down these earth anchors. And we started doing test drilling, and we found out that unfortunately this was the place in Denmark where the rock, or the chalk as it actually is, was the lowest. It's more than 30 meters down on the ground. So the earth anchors had to go down there because about 20 meters down, where we thought we only had to dig down, there was a layer of old fish that is almost like a sponge. So if you try to anchor into that, it just it just keeps on going up. So the engineers came up with this ingenious idea of actually sending down divers and drilling the holes through the concrete floors underneath 8 meters of water, which we thought sounded a little bit like building Atlantis, or but it was actually not the architect but the engineer that thought that was the best way. And then we tendered it out, and all the contractors came back to us and said, like, we are not going to do that. We can do it, but we're not going to be liable if water starts leaking in. So each of them came back with different solutions for how to treat this. And the one we ended up doing was basically doing a 30-meter deep wall around the museum that goes into the chalk and makes the construction pit impenetrable from water. It's done by these, it's called benzonite. It's called a slurry wall. It's what you normally do to make metros when you do it in historical areas. Each of these big grabs are about 10 meters tall, a little bit like kind of as tall as this space, and 4 meters wide, but only 60 centimeters deep. And then they dig these kind of narrow walls all the way around, and you pour in benzonite, which is this very thin concrete that acts as clay, and the water can penetrate it through it. So that's basically what we did. Then we could pump out the water, and then we could anchor them in, and then we could start anchoring in the dock. This is a drawing of all the horizontal anchors, and there's 466 anchors going down to the chalk in the other direction. But that was the cheapest way of doing it, instead of using divers. And then we decided to leave the earth anchors visible in the dock as a testament to this effort that has been spent on preserving the dock. So all these earth anchors are actually what you see the caps on top of here in the dock. And this is how the excavation site looked. It felt more like being an archaeologist than being an architect until the day where it was finally done. As a last thing, I'm just going to show a little film. Can somebody turn up the sound? No.
Tale om søens verden. Og det ligger selvfølgelig meget fjernt fra dem. Men som sagt, opfand det ikke som en lille ekskursion fra deres daglige arbejde.
Thank you very much. Thank you very much.